To get into the details of a hash algorithm, we will, as we often do, look at the older, now insecure version, but it has the same ideas that are used by more modern secure versions. With MD5, we take a plain text and break it out into 512-bit chunks. If the input that you want to hash is not a multiple of 512 bits, or 64 bytes, then you add some padding to the end. That padding is a single 1 bit, then 0 bits, until you get to a multiple of 64 bytes minus 4. We'll use those last 4 bytes to record the length of the yellow part, the part that's in your original message. This length makes it a little harder to find collisions because it means that an attacker doesn't get to play with the padding, the ones and zeros there, to try to arrive at a hash collision. MD5 takes these 64-byte chunks and feeds them into the same function m that we'll describe in a moment. This m function, in addition to one of these chunks, also takes the current value that's being accumulated towards the final hash code. We need a value for the very first chunk, and so we start with an initialization vector. And this value that we're accumulating is always, like the result hash that we want at the end, 128 bits. In principle, you could vary the initialization vector here to get different hash codes out. But in the MD5 standard, then we always use this particular 128-bit number as the initialization vector. The m function on the inside is going to do a different function 64 times, or variations of a different function. This is m sub 0 through m sub 63. Each of those functions is going to take the current accumulated value, make some transformation on it, and we'll get a number that we then add to the current value to feed into the next step of the algorithm. Each of these 64 boxes looks like this. The box gets in the chunk of our message. That is a 64-byte chunk. And it also gets the current accumulated value, which is 128 bits, 16 bytes. We'll break up those 16 bytes into 4 equal-sized pieces of 4 bytes each, or 32 bits. And you see this pattern that we've seen before, where B goes to C, C goes to D, D goes to A, and nothing changes with those. Meanwhile, we take A and mix it up with all the other parts to get the new B. And each step in the 64 MIs will use a different piece and mix them all up and cycle through all of these pieces. The 64 bytes that come in here need to be mixed with just 4 bytes here from the AI and mixtures of BI, CI, and DI. First, we use this GI box, which will pick 32-bit words, that is 4 bytes, from within the 52-bit or 64-byte chunk. There's 16 such words within the chunk, and it turns out that G0 through G15 just take one of those each, and then G16 through G31 counts by 5 instead of going by 1 and cycles through all of them that way, and then the next set of 16 go by 3s, and then the last set of 16 go by 7s. So each of these MI boxes is getting 32 bits from our current 512-bit chunk, and mixing that in with the result of F on ABCI. F sub I is for F0 through F15, it's this function, which ends the bits from A and B, and then ORs it with the knotted bits of B, and it with D, and so on. It turns out there's 4 different functions used by 4 different sections of the 64 MIs. Similarly, the KI here varies based on I. That comes from the sign function, where it's taken the absolute value. But the overall picture is that we are mixing B, C, and I through some nonlinear ANDs and ORs and XORs, adding it with the current AI, then adding that with some bits from the input, then adding it with some constant, then shifting by an amount that also varies among these different M sub i's, adding that one more time with B sub I, and that becomes the new BI plus 1. So again, we're chaining those kind of boxes 64 times, which means that this whole calculation can take a while. So we use MD5 and similar hash code calculations in context where it's worth spending the time to do this calculation. To ensure message integrity, we need to do all of this work to get a large number of bits out in our hash code and avoid the possibility of hash collisions.